All right, let's talk about cracking the code on one of the toughest, most demanding interviews in tech, the data engineering interview. We're going to jump right in and lay out a map for you to get that offer. First things first, you need to think of this less as a stuffy interview and more like a gauntlet, right? It's a series of intense challenges designed to test your skills, your speed, and how you think on your feet. It's definitely tough, but trust me, it's absolutely conquerable if you know the layout. And that layout, that map, it's all built around count 'em, five core competency areas. We're going to treat these like levels in a video game, the key challenges you've got to clear to win. So what are they? Well, these are the 5 pillars of data engineering: SQL mastery, Python and data manipulation, ETL and warehousing, big data and cloud ecosystems, and finally the big one, system design. If you can show you're strong in each of these, you're going to be in a fantastic spot. So let's dive into level 1. Okay, level 1. Every great warrior needs their core weapons, right? For a data engineer, that's SQL and Python. These are the absolute non-negotiable fundamentals. And honestly, SQL is often the very first and most important gate you have to get through. So when it comes to SQL, joins are everything. The key is knowing exactly what data you want to keep. An inner join, well, it's exclusive. It only gives you back rows where there's a match in both tables. A left join is more inclusive. It brings back everything from that left table, even if it doesn't find a match on the right. Knowing which one to use and why is table stakes. You will almost certainly get a question like this: find the duplicates. The method is actually pretty simple, but it's powerful. You use group by to bundle rows together based on whatever columns you think might have duplicates. Then you just use count star to count how many are in each bundle, and the magic having clause to show you only the groups where that count is bigger than 1. It's a classic test of how well you understand aggregation. Okay, now this one is all about trade-offs. There's no single right answer. Normalization is all about keeping your data clean, consistent, and with no repeats. It's perfect when you're writing data all the time, like in an app's backend database. But denormalization, you're actually duplicating data on purpose because it makes reading that data so much faster. And that's exactly what you want for analytics and reporting. All right, switching gears to Python. This is a classic gotcha question. What's the difference between a list and a tuple? It all comes down to one word: mutability. You can change a list after you make it, add stuff, remove stuff, whatever. A tuple is locked in. It's immutable. You use it when you absolutely need to guarantee that the data inside won't get accidentally changed. Decorators. I know, they sound super complicated, but they're really not. Just think of them as like a little power-up you can wrap around an existing function. You need to time how long a function takes, or add logging every time it runs. You can decorate it with that extra functionality without having to rewrite the whole thing. It's a really clean, really powerful feature they expect you to understand. Okay, so our foundational weapons are sharpened. We're ready for level 2. This is where we go beyond just writing commands and start actually building the systems that move and store all this data. This level is all about data pipelines and warehousing. You have to know this. This is one of the most important distinctions in modern data engineering. The old way, ETL, meant you had to transform and clean up the data before you put it in your expensive data warehouse. But now, with super cheap cloud storage and crazy powerful cloud warehouses like Snowflake or BigQuery, it's way easier to just extract and load all the raw data first. That's the EL. And then do the transformation, the T, using the massive power of the warehouse itself. Look, anyone can build a pipeline that works when the sun is shining, but a real production-ready pipeline has to be robust. That means it needs automatic retry logic for when things fail. It needs monitoring and alerts so you know the second something breaks. It needs data quality checks built right in. And, this one's crucial, it has to be idempotent. That just means you can run the same job over and over, and you'll get the exact same result every time without creating weird duplicates or other problems. So, the data lake. The easiest way to think about this is like a giant, super cost-effective storage reservoir. You can just dump everything in there, structured data like tables, unstructured stuff like logs, images, CSVs, you name it. And you store it all in its original raw format. It's basically the starting point for almost all modern big data work. And now for the boss level, level 3. This is where you go from being a builder to being an architect. It's where big data concepts and system design all come together. They don't just want to see if you can write code anymore. They want to see if you can design an entire complex system from scratch. So they'll hit you with a big, open-ended question like this. There's no single perfect answer here. What they really want to see is how you think. How do you get data from a source, process it instantly, and get it in front of users in just a few seconds? So, your answer should look something like this flow. You've got to pick the right tool for each stage of the data's journey. For ingestion, you might grab Kafka, which acts as a big buffer for all the incoming data. For processing, maybe Spark Streaming to transform that data on the fly. Then you'd land it in a cheap storage layer like S3, load it into a super fast data warehouse for querying, and finally, serve it all up to the business in a dashboard. So why is Spark always the engine people pick for this? Well, it comes down to one thing: speed. Unlike the older systems that had to write data to a slow disk between every single step, Spark does as much work as it possibly can write in memory, which is just ridiculously faster. It really is the workhorse of big data processing today. And then on the warehouse side, you have platforms like Snowflake that completely changed the game with this new architecture. The secret sauce, the real innovation here, is separating storage from compute. What does that mean? It means you can scale them independently. If you need a ton more query power for an hour, you just spin up a bigger compute cluster, and it doesn't affect your storage at all. It makes things incredibly flexible and way more cost-effective. Okay, we've covered the core technical levels, but just knowing the material is only half the battle. Now let's talk about the winning strategy, the skills around the skills that tie it all together and actually land you the offer. I need this to sink in. I said it at the beginning, and I'm saying it again because it is that important. If your SQL is weak, you will not pass, period. It's the language of data, it's the first gate they put you through, and for a lot of people, it's the last one they see. You need to practice SQL until it is second nature. So beyond the code itself, this is what they're really looking for. Don't just say, I used Spark. Say why you chose Spark instead of something else. Show them you understand the trade-offs. Don't just describe a pipeline you built, explain the business problem it solved and the impact it had. And most importantly, especially in that system design round, talk them through your thought process out loud. They want to see how your brain works. Communication is a huge part of the job. So there you have it, the gauntlet, the levels, the winning strategy. The map is right here in your hands now. The only question left is, what's the first challenge you're going to go conquer?